Okay, solution to the next question, which is number 2, is what we want to quickly do. So we're told if A, B, and C are real numbers such that A minus B is 1, B minus C is 1, C minus A is 2, and ABC is 60, find the value of what we have here. So, like what I usually say, let us start by considering what we have in the required part of the question. So under the requirement, we are given this. Now, before I jump into using what is given or what are given to me, it is best we consider this required first. Whether combination is possible, whereby it leads to some identity. So, but the structure of what I have here, I think it is worthy of being considered. So let's first of all consider this thing. How do we consider it? Let's try and combine them together first. So what this gives will now tell me how to manipulate my given. So in that situation, so here I have BC. I want to add this separate. I want to combine this separate. Then later on, I can combine everything. So BC, AC, AB. So normal addition. So we can see this gives the LCM of ABC. Right? So BC in ABC gives A times A here is A squared. AC in ABC gives B times B, that is B squared. Plus AB in ABC gives C times C, that is C squared. So let me now say, I want to combine all of this, right? Or why not treat it together? Let's treat it once. We can treat everything together. So LCM still remain ABC. All right. Now A in ABC gives BC. BC times 1, that is BC. B in ABC gives AC. AC times 1 is AC. And C in ABC gives AB times 1, that one is AB. So we can see when this thing is combined, it gives something meaningful. Reason being that when we observe what we have in the numerator here, right, it is a known identity, if we can recall. This is a known identity. Also, when we consider what we have in the denominator, right, so I simply can say ABC is already given to be 60. So what I will now do is, how can I use the given, right, to give this result that I have here? Remember that I will not just go straight into the list of identities which we have memorized or that we know and just place it. No. What we want to do with this is it possible for me to combine this, and this to give this result? So if it is possible for me to do that combination, so this one I will have to pause here. So possibly let me separate my body into 2. Let me go and deal with the given parts and see whether that one will also give something of this form. Once it gives something of this form, then in its own case, it will be equal to something. So whatever it is equal to is what I will just use to replace all I have here. Since ABC already has divination, so ABC is equal to 60. Since ABC is equal to 60, you can see that from the given, what we have here, all I need to do now is, I want to adjust this, and this. Possibly, it can give me something of this form. You can see the denominator already has a perfect match, right? So meaning that if I'm able to combine this equation 1, this equation 2, and this equation 3, if it gives something similar to it, the value of such thing is what I will just use in the numerator, since I already know what I will use in the denominator. Since the denominator contains ABC and ABC is defined as 60, this one automatically changes to 60. So that's what we want to do there. So let's go straight into our first 3 equations. So what are those equations? We have A minus B is equal to 1. So I can say equation 1. I have B minus C is equal to 1. So that is my equation 2. And I also have C minus A is equal to 2. That is my third equation. Remember, this thing here tells me how to relate with this thing. So what do I mean by that? We can see somewhere here we have square. So that shows, why not square this thing? Do you get, how can I achieve, okay, here I have a squared, I have b squared, I have c squared. Now here it's not just a single a or e raised to power 1 that I have, just single b or b raised to power 1 ditto for c is what I have. How can I, remember I said this one tells me how to deal with this thing. Now that I know how I want to deal with this thing, I now have to generate a question within that. How do I manipulate this thing to give something of this type? I can pick just only one. Now here, for instance, I have a squared. How can I manipulate everything here to get a squared? You can see b also is written to have coefficient of 1. And here, b is combined with c. How do you think this thing can be combined? In order to have bc, in order to have ac, or in order to have ab. So that shows that can be achieved, right? By, let's say we want to square all of this thing. Possibly when we square it, it is possible it gives something of this type. Okay, so in order to do that, let me square this. So if I square this one, a minus b squared. Okay, I want to square everything, not just only a minus b. So now what we want to do is, let us square everything. Let us square everything. So like this, let me say squared. This one will be squared like this. Let us square this, we square this. Let us square everything. So the motivation to that was because I have a squared. And if I want to get a squared, so I think one of the things I can do is I will square everything, both the left hand side and the right hand side. Remember, it is not limited to those squares. And after they square them, it's like the combine. Let's just square it first and combine and see whether we are going to get something of this type. Now remember, from our basic identity, when we have a minus b squared, what this thing changes to is a squared plus b squared, right, minus 2ab. We say it is equal to 1 squared gives what? 1. So I can restate it as what? My equation 1. So similar thing has to be performed in the second equation. B squared here becomes b squared plus c squared, then minus, since it contains minus, it will be minus, I will have to double this b and c at the same time, minus 2bc is equal to 1 square here still gives 1. This is still my equation 2. I'm not solving simultaneous equation. I have no cause to call it equation 3, 4, and so on. So here, 2, if I square this, becomes c squared plus a squared minus, remember, that becomes 2ac is equal to what? 2 squared in this case gives 4. This is my third equation, right? Now, how can I combine this thing to have something like this? So I think that can be achieved by addition. Because here I have a squared plus b squared plus c squared. So if I'm to subtract, so this one will contain minus, this one will as well contain minus, and those squared values, those squared variable rather, do they contain negative sign? They didn't. So that shows these things were added. This thing, adding it together will enable me to get this. So doing that becomes, I want to add everything. So it will now be a squared plus b squared minus 2ab, so the left hand side first, plus b squared plus c squared minus 2bc plus c squared plus a squared minus 2ac is equal to 1 plus 1 plus what? Plus 4. Right? So to continue with this, we want a, b, c to be together. Look at this one, a squared. So to make it fast, I can say plus a squared here gives 2a squared. B squared plus b squared, that becomes plus 2b squared. C squared plus c squared, that becomes 2c squared. Right? So after that, so I have minus 2ab, which is this. I also have minus 2bc, and I also have minus 2ac, which is equal to 6. So what can happen here is 2 is common to them all through. I can divide throughout by 2. So I can say this over 2, this over 2, this over 2, over 2, throughout like that. So when those 2 are cancelled out, so this one 2 changes to 3. What I have left is a squared plus b squared plus c squared minus ab minus bc minus ac or ca is the same thing, minus ac is equal to 3. So which means a squared plus b squared plus c squared minus bc minus ac is here. So it shows this given here. Combination of this given is this. Why the other given value is this. I can now progress with this and say this one is equal to. So this, my manipulation told me here that this combination has the value of what? The value of 3. So I will now say that one is equal to 3 over. What is my ABC? ABC is equal to 60. 3 over 60. Yeah, we just cancel where possible. 3 in here, 1. 3 in 60 is 20. So that shows the final answer to this question is what? 1 over 20. And that is just the simple solution to our second question. So, like I said at the end of the first question we solved, I said dealing with most questions in identity, so we should prepare for the worst, especially in situation whereby the identity we are not going to apply the identity directly. So we may need to carry out some adjustments. So in order to be able to do what? To now apply our identity. So that is how far we can go today with this problem, solutions to the given problem. So remember these 2 questions which is solved today is just the first set out of many sets that we have. Remember I told you that 50 questions has to be solved by every student to actually show that your interest is in preparing for this Olympiad examination. And for those who have not joined us but who are just doing this thing on Facebook or whatever platform you are watching it from, kindly kindly follow us on what we do here. Subscribe to this channel, make a comment, and help share this thing to Nigerian students that you know might be of interest in this thing which we are doing. So to some extent, this is outside the scope of secondary school mathematics. So it requires special training. So the skill on how this kind of questions is going to be approached has to be learned. And once it is learned, we'll be comfortable in writing the exam and we'll be able to represent our country, and we can bring gold, we can bring any medal for our country. Is one of the way our contribution towards showing that we have the interest of our dear country in our mind. So on this note, I'm going to draw the curtain till when next we are going to meet. I appreciate you for being member or for being part of this great learning platform. I hope to see you in the next edition of our video. Thanks for watching.